So in this video, we're going to learn how to verify functions that are inverses. So to verify a function, if they are inverses, they need to show that the composition, when you plug g into f or when you plug f into g, that they result into just 1x. They have to give you out 1x, and that's how you tell if something is an inverse to each other. Now, it doesn't matter which one you decide to use, you have to use one of them. But the other way you can figure out if something is inverse of each other, so let's say I have these two equations. I want to know if they're inverses to each other. What you could do is take one of the equation, find its inverse, and if that equation matches up with g, then that's good. You know that they have to be inverses to each other. So that's one way to prove it. But for now, I'm going to show you the composition way because I think it's a little bit faster. So what you do is if I want to determine if these two, let's zoom out just a little bit. If these two equations are inverses to each other, I'm going to use the composition. And I am going to just do the f plug g into f. I'll start with that one. And let me color code this so that way you guys know which one I'm referring to. So I'll make f green and g pink. So I would have to grab g's equation. So taking this here, I'm going to plug that in for g. So that's negative 1/3 x plus 2. So I'm going to plug all of this in for f. So that means if I go back to f here, I'm taking this x and I'm plugging all of this in for x. So that's going to be, negative 3. Instead of that x, I'm plugging in what I'm given here, which is negative 1/3 x plus 2. And then after this x, there's a plus 6. So let's bring that down. Okay, from here, I need to simplify this. So I'm going to distribute the negative 3. So these two are negative, so it'll end up being a positive when I multiply. And 3 times 1/3, that 3 is going to cancel out with that 3. But if you can see, 3 times 1 is 3. 3 is in the bottom, so that's going to be a 3 over 3, and that's a 1. So they'll end up canceling each other. So this ends up being a positive 1x. And then negative 3 times 2 is negative 6. And then there's a positive 6 on the side, so I'm going to bring that down. Now, I can see already that the 6's are going to cancel each other. So all I'm left with is a 1x. But a 1x is really just x. So that means these two have to be inverses of each other because as long as g of x is equal to x, as long as your composition function gives you x, they are inverses to each other. That's how you test them out. And so from here, I know that yes, these are inverses. All right, let's try another one. So maybe this time let's do the other composition function. Like I said, it doesn't matter which one you use, but this time around I'll do g plug in f. And again, I'll color code these so we're on the same page. So I'm going to be plugging in my f this time, so let's replace that guy. So you have g plug in f, which is 2x plus 3. So this is my f here. And I'm plugging all of this in for g. So here's my g equation. I have 2, instead of this x, I'm plugging in 2x plus 3. And then there's a minus 3 here, so I'm going to bring that down. So once I have my composition written, I'm going to work this out. So maybe distribute the 2. So that gives me 4x plus 6 minus 3. That's to the side that it brought down. Now I can already tell this is not going to be an inverse function because this is not going to result in just being 1x, right? This 6 and 3, if I simplify that, this is going to be 4x plus positive 3. And this is not... I can't simplify that any further, and this is not 1x. So this is not an inverse. So oftentimes, like a student will plug things in, and they can already see it's not going to work out because they know it can't result into a 1x. But I would always say, keep working it out until you can simplify it down to something you can't no longer simplify, and then determine if it's an inverse or not. All right, let's take a look at this next one here. So this next one's interesting. You have a negative 6 and a 1 over 6. Maybe they're inverses because this one's a negative and this one's a positive, and this one is the reciprocal to 6, so maybe. But we won't know until we find the composition and check. So I'll just do f of g this time. Usually I just use f of g, but it's up to you, whichever is easiest. So I'm going to plug in my g here on the inside. So g is going to be 1 over 6x. So this is f, plug in my g, which is 1 over 6x. I'm going to plug all of this in for f. So here's my f. I have a negative 6, so let's write that down. So this is negative 6, and then instead of this x, I'm going to plug in what I'm asked to plug in, so 1/6 over x. 1/6 over x. And again, this is a fraction, and 6 is a reciprocal because 6 over 1, right? And so if I multiply these two, they will cancel each other, leaving me with just that negative sign. So I have negative 1x. So, by the way, if you don't see what I'm talking about with the reciprocals here, if you work this out and multiply, 6 times 1 is 6. 1 times 6 is 6. And so that's how I got the 1 there. So there's a negative sign that I dropped down. When I multiply the 6 with the 1 over 6, I got a 1, and I dropped down the x. From here, this is interesting. This is not 1x. This is negative 1x, right? So this is not what our verification says that needs to be a 1x. So this does not count. So this is not an inverse. So it has to be a positive 1x, not a negative even works. So no negatives would work here either. So this is not an inverse. All right, this next one here, we have f and g. So I'm going to go ahead and color code these. And I'm just going to use f and g. So my g here is this 1/4 x plus 2. So I'm going to go ahead and replace that with 1/4 x plus 2. And then from here, I need to plug all of this in for f. So I go to f, and if there's a 4x, so let's write that down. So there's a 4, and instead of an x, I'm plugging in all of this. And then there's a minus 8 after. From here, I need to work this out, so I'll distribute the 4. And again, 4 times 1 over 4th is going to end up being just a 1, or canceling. But make sure you don't forget the x. So if you didn't see that, one more time, 4 is actually 4 over 1. So if you multiply 4 and 1, you get 4 on the top. 1 over times 4 is 4 on the bottom. So 4 over 4 is a 1. That's how I'm getting that number. And then 4 times 2 is 8. And then there's a minus 8 to the side that I'll go ahead and bring down. And I can see that the 8s are going to cancel each other. So I'm left with just that 1x, or just x. So this is definitely inverses of each other because you get 1x as your composition. And that's how you know that they are inverses. So yes, they are inverses. And that's it. So I hope you guys found this video helpful. If you look down below, there's some more practice problems you can try out. Bye, guys.